you can hopefully pick that page out. Of course, you can always go by date, right? Nice. So we're doing chapter 4. Chapter 4 is pretty quick. So I'm saying, I'll just try and do this schedule again real quick. So we're in week 9, Tuesday, Thursday. I'm going to do 4-2, half of 4-3, and the project today. So probably a little bit much, but we'll see what I can get done. And then I'm going to finish 4-3 on Thursday and do 4-6. And then week 10, I should be able to finish up with 4-1, which means week 11 would be, if you were taking the chapter 4 test, it would be there. But you're going to take another midterm, chapter 4 and 5 together. And then what did I say for chapter 5? I had it written up here. I think it's week 14. So there's our midterm 2, right? Chapter 4 and 5 only. And then the final is, the way I do my finals is I pick all of the questions that most of the students had the most trouble with, and I change them a slight, right? And say, here's your final, right? So if you did really well on both midterms, the final will be very easy for you, right? So I'm just going to pick, 10 problems from the 2 midterms, change the function or change something about it, right? And ask you to do it again. So a derivative using a limit, a tangent line, right now we're looking at, right? An inverse trig derivative, right? Et cetera, et cetera. Nice. So chapter 4, which is boring as all. And so make sure you're taking those Advil before class because you will have a headache, I promise. We do 4-2, which is absolute min and max. We do 4-3 in 2 pieces. We have a first derivative test. And then we do 4-3, a second derivative test. We do something in Calc 2 with the fourth derivative. And then I do 4-6, optimization. This is the cool stuff. This is you're building phones, let's say your company, and you're trying to find the right amount of phones to produce in a month, in a year, etc., that will maximize your profit, right? If you build too little phones, you're not selling anything. If you build too many phones, you're probably buying too much material, right? So you'll start to eat into your profit that way. And so this is calculus. This is a way to figure out where is the perfect level of production to make the most money, right? That's optimization. And then 4-1 is related rates. It's a little bit weird, so I put it last. There is a section in there about Newton's method, but you're doing that in your project. There's a section in there about L'Hopital's rule, but we learned that already. There is a section in there about antiderivatives. I just grouped that into chapter 5. So that's it. So you can already see 5 questions on your next on this material for the midterm 2, right? Maybe 4. Nice. So let's start with 4-2 today. And basically 2 types of problems in here. We're talking about absolute min and max, and you'll see local min and max as well. So absolute min and max. And so what I'm simply talking about is, can I find a low point on the curve? Can I find the high point on the curve? That's it. That's what I mean. The highest point on the curve, the lowest point on the curve. Very simple. So, right, so this would be my max, and this would be my min. What's kind of weird is this guy's called a local. It's not an absolute max. It's called a local max. Local meaning when I'm on that part of the hill, right? I'm higher than I'm further up. I don't want to say higher. I'm higher in the air compared to anyone close to me, right? So like if anybody was real close to me, right, I'd be standing higher than them. Yes, there's another higher part of the mountain, but I don't care. It's way over there, right? All I care about is really close to me. In fact, how close? How close do I care about? What's that? Closer. A tiny positive number called delta. So within any delta, I want to see if I'm the at the highest point compared to anyone else. So we got two types of problems here. The first one is simply finding critical values, right? So problem type 1. Find f prime and find the critical values of f prime. What does that mean? It means yeah, that's why we've been factoring so much, because I need to find the zeros, right? So the critical values of f prime say f prime of c equals 0, or f prime of c does not exist. So the critical values mean when is my derivative 0 or when does my derivative not exist. This turns into when the numerator is 0, and this one turns into when the denominator is 0. Meaning of my derivative, right? So that's why in fact factoring so much, because if you factor it, it's easy to find zeros. You've been doing it since 8th grade, right? What'd you have to do in 8th grade, 9th grade maybe, right? Y equals x squared, don't tell me, minus 2x minus 3, right? Right, you remember learning this? So this is, I call it AC easy. All I have to do is find factors of -3 that add to -2. What are they? -3 and +1, right? And then I can see that I'm going to have a 0 at -1 and a 0 at 3, and there's my parabola, right? We've been doing that for a long time. We've been doing that. And we've been torturing you with all of this algebra so that you could be ready for calculus, right? So zeros, right? Zeros of the numerator, zeros of the denominator of the derivative, right? Let's do one. Let me open the textbook. Nice. So I think I like problems 1 to. I'll assign homework next week. From 4.2, I like problems 1 to I think 71. So you can start working on those right away. Let's do 33. So I've got a function, I want to find the derivative, I want to find the critical values, right? So this is 4.2, number 33. So what's nice about this is you already know how to do all this stuff. And you'll see most of the stuff in chapter 4, you know how to do it already. You know how to do this project that I'm going to talk about today. So I've got f of x is equal to x minus 1 over x squared minus x plus 1. You're going to be graphing these things all the time, so get used to it. Almost everything we do in chapter 4 will involve a graph. I want you looking at that graph right away. I'm going to use Desmos right now. I'll do something on the calculator in a little bit. So I've got f of x equals to x minus 1 all divided by x squared minus x plus 1. There it is, pretty cool. So you can see a couple things. You can see a low point, right, of the curve, yeah? You can see a high point of the curve, yeah? You can drive and see when you're changing your steering, right? So we're talking about critical values of the first derivative, critical values of the second derivative, right? The first one will give me low points and high points. The second derivative give me concavity, right? Is it smiling or is it frowning, right? Concave up, concave down. Nice, let's get our derivative. On your mark and set, go. Don't copy me, just do it, right? Give you another minute. Got to make it a game, right? Make it fun. How we do? Anyone else get there? Nice. You might need another minute. By the way, after you take Calc 2 and pass it, You can tutor in the Math Learning Center. So if you're going to take Calc 2 over to summer, they need tutors in the Learning Center for fall. If you've taken statistics, you can tutor right away, and they probably need you right away. I forget what you're paid, $12 an hour, $14 an hour, I forget. How we do? Who got there? Nice, nice, good. Critical values, right? So we find the derivative and we find the critical values. So I want to find C such that f prime of C equals 0, which means x times 2 minus x equals 0, which means x equals 0 or x equals 2, right? Yeah. And then I want to use the original function to get the point on the actual curve. With Desmos, it's kind of sweet. I can just say 0 comma f of 0, and it will give me that point. You see that the low point on the curve, and I want to find 2 comma f of 2. And of course, you'll actually find the value of it, but for now, we can just see that's the low point and the high point, right? Does that make sense? I think the low point's pretty obvious. It's -1, right? Yes, you agree with that? So I can just replace that with the -1. And the other one is 1/3. You agree with that when you plug in 2 to the original function? Can you do that in your head? I hope so. Yeah, when you plug 2 into the original function? Right, upstairs is 2 minus 1, yes? So that's a 1. Downstairs is 4 minus 2 plus 1. So 4 minus 2 is 2 plus 1 is 3, 1/3, right? So notice what the slopes of my skis would be there. They would be 0, right? I'm standing on the top of a hill. My skis are perfectly parallel to, I don't know, curvature of the earth or the ground, x-axis, whatever, however you want to think about it, right? I also have to find, I want to find C such that f prime of x does not exist, right? That's the same as saying the downstairs is equal to 0, right? Well, square root that. It's the same as saying that inside is equal to 0. And I before I do any work on this, I'm going to graph that. I'm going to graph it, because if I graph it, I could probably tell right away, is it factorable or not? Or does it have zeros, right? What is that? Y equals x squared minus x plus 1. And I can see that parabola, oops, oh, that's cool, x to the x. I can see that parabola does not hit the x-axis, so I know it doesn't have zeros. What kind of shape would my skis be in if the downstairs is 0? You remember calling it undefined, right? That means infinite slope, positive or negative, you can't tell. So if I had a critical value from downstairs, it could possibly give me a vertical tangent line. First derivative, when it's equal to 0, I could get a horizontal tangent line. When it doesn't exist, I get a vertical tangent line, right? For example, at 1 over x, right? So f of x is 1 over x, square root of x. And the derivative, which we have memorized, is 1 over 2 square roots of x. And what x makes that downstairs 0? Duh, 0. So if I looked at the curve at 0, I would see a vertical tangent line at 0. So numerators give me possible horizontal tangent lines, tops of a hill, bottom of a valley. Downstairs give me possible vertical tangent lines, right? Where the curve is so steep, I can't even tell what the slope is. Nice. Let's do another. Sure. Talk to me. Yeah, this one doesn't. So look at that purple curve, right? It doesn't hit a 0. So there's no zeros downstairs. right? I have to check for zeros upstairs, zeros downstairs in the derivative. Yeah, so I didn't do anything else with it because as soon as I saw that it didn't have a zero, I didn't have to find a critical value. Let's do another one here. Oh, 39. We love our trigs, right? 39.
So what's the answer then?
The critical values are 0 and 2.
And what's the use for the x squared minus x?
It doesn't equal 0, right? I looked at the graph, right? I looked at the graph and I said, oh, well, look at that purple graph. It never equals 0.
Oh, so this will be like it's impossible answer.
Yeah, no answer.
Okay.
No criticals from the denominator.
Do you remember how, like, if it was, for example, if it was like x minus 1 at the top and then x minus 1 at the bottom, that would be a whole?
Exactly. That's a whole, and they would cancel.
Are we going to have to deal with that?
No, because we already know about it from doing our limits. Yeah.
So what
But that is a good hint that if you have a critical value matching in your numerator and denominator, you're probably not done with your algebra. Question?
So what we're doing here is like look at the purple line to see if it touches the fx.
Yeah. And then I know it's got a 0, and that means it's a critical value, right? Good. Let's do another one. This is a trig 39. So this is 4.2, number 39. And we want to look at f of x equals to 2 cos x plus sine squared x. Of course, it's good to look at the curve, right? Always once you're looking at the curve. And on this one, we zoom trig, 2 cos x plus sine squared x. There it is. So again, I can see, well, I know there's not going to be a denominator, right? Because I'm taking derivatives of sines and cosines. But I can see tops of hills and bottoms of the valley, right? Right. And if I change my scaling to something trig-ish, like pi, I can actually see all my critical values right away, right? They happen at k pi, negative 3 pi, negative 2 pi, negative 1 pi, 0 pi, 1 pi, 2 pi, 3 pi, right? You see it? So going back to that pre-cal class where you had to find zeros of a trig function, that's why we did that to you. That's why we tortured you with it so much. So let's do it. Let's do this problem. So we're going to find the derivative. Pretty easy. So f prime of x, derivative of cosine is negative sine, and derivative of sine squared is 2 sine x cos x, right? I had one like that on your midterm. I do see an identity there on the right, but because I'm back in my pre-cal class, I know when I'm solving trig equations, I want to factor if I can. And so I can factor out a negative 2 sine x. And what's left is 1 minus cos x. Agreed? Some kind of nod or grunt would be great.
So the sine squared is 2 sine cosine.
Yeah, so remember, if I say y equals sine squared x, I'm really saying y equals sine of x all squared. But we write it the first way because it's neater,
Yeah.
quicker. So outside function is squaring something. Inside function is a sine function. So derivative of the outside is 2 times that something, and then times the derivative of the inside, which is cos x. So 2 sine x cos x.
So what I did, I multiplied it times cosine using the
Chain rule.
yeah,
Yeah,
using
yeah.
and I multiplied it and then
Yeah, so that's the x squared, becomes a 2x, right? But keep the cat in the box. So it's not a 2x, it's a 2 times sine. And then derivative of the inside is cosine. So now we don't have a denominator, which is nice, so we just have to find criticals for when f prime equals 0, right? F prime of x equals 0 tells me what? That negative 2 sine x equals 0, or 1 minus cos x equals 0. So the first one says, oh, that means just sine x equals 0, or cos x equals 1. Those are both easy, right? So you learned how to graph your sine function and your cosine function, right, in your trig class and in pre-cal. So sine, right, I'm doing those quads, I can see every pi. So x equals k pi. And then if I do cosine, I only get at even pi's. So 2k pi. Right? Agreed? When do I get cosine equal 1? At 0 pi, at 2 pi, at 4 pi, at 6 pi. Right? You remember doing those in pre-cal? Where you had to say, oh, it was pi over 6 plus another time around the circle plus 2k pi. You remember doing that in pre-cal? So I see all my criticals. So I have to kind of marry the two answers here together, and I can see that's a good enough answer, right? Every value of pi. Every integer times the pi, right? Nice. Let's go on to problem type 2. We okay? Remember, you're going to energize, right? You're going to energize. You're going to find some power somewhere. You're going to find someone to work with. You're going to ask for help. You're going to do everything you can to increase your understanding and ability in the class, right? That's what we want to do. Or we give up. We don't want to do that, right?
So what is
K is an integer. Yep, so K belongs to the set ... -3, -2, -1, 0, 1, 2, 3, ... etc. Integers. The curve? You want to look at the curve?
No, I mean like, so like, to look at the degree,
The degree?
yeah.
What, a degree of what?
I mean like, for sine x equals 0, so we know that, when sine is at 90.
Yeah, we try and keep it in radians now, but yeah, so pi, 0, pi, 2 pi, 3 pi, 4 pi, etc. So k pi.
Oh.
Yeah, yeah. Nice. Our new problem type is, so this is problem type 2. We're saying if f of x is continuous, on a closed interval, right? From like 0 to 1 kind of interval, right? But it includes the endpoints, right? Closed interval. Yes, you with me? Then f must have an absolute max and an absolute min on the interval. And f of A, f of B, f of C, where C is a critical value of f prime, are the only candidates. There's no other option. I will not find that maximum at any other point. It's kind of hard to believe, but so it has to come from the endpoints or the criticals in between the endpoints. So it should be kind of obvious what we're going to do. We're going to take our function, graph it, restrict the domain, notice where the highest point is, where the lowest point is, find the values at the endpoints, find the derivative, find the criticals that are within my endpoints, find the value of the function there, make a conclusion. I will write that all down. Okay? So one of the things you're going to have to do on this next exam is have step-by-steps written out, because they're so long and complicated, you're not going to remember them. Right? Well, if you practice enough, you will. If you practice enough, you'll remember anything. Like how easy is it to brush your teeth? Anybody want to share their process? What do you do first? Oh, brush, just the brushing after the floss. What's that? Nice, pick up the toothbrush. Second step? What's the second step? Okay, so you got to turn on the water. Okay, so you're the pre-soaker, right? So now turn off the water. Then what? You got to get the toothpaste, right? So I got to pick up the toothpaste, and I'll still hold the brush, open the lid, put the lid down, you see, it's quite complicated, but we've done it so many times, you don't have to think about it. And that's what I'm saying. You've got to practice calculus with the intent of no cavities. Nice. So let's look at our step by step here. Graph the function. And notice the calculus. So easy. Calculus is so easy. You can just look at a function and know the criticals and know which one is the highest and the lowest. But then to do the algebra is a different story, right? Step 2, find f of A and f of B. Find the value of the function at the endpoints, right? Find f prime and the critical values. That are within the endpoints. I don't care about critical values outside of my endpoints. And I don't care if a critical value is an endpoint, because I already know the height at the endpoint. I found f of A, I found f of B. Find f of C and conclude. Which one is my highest point? Which one is my lowest point? Right? Maybe then graph them too. Double check it. Right? Yes? Exactly. So once I check, once I find the endpoint, how high, what the height of the graph is on the endpoint, if I get a critical at that same endpoint, I already know the height. Remember, that's what I'm trying to do. I'm trying to find the highest height, the lowest height.
Right. You said if it's not closed, it doesn't matter if you get the same number.
That's right, because yes, exactly. So the thing is that the function must be on a closed in order for this to work. Like if you think about like 1 over x, right? Is there a max height on that graph? Is there a max height? No. I mean it's infinite, but if you get to infinity, call me and I say go up another foot, right? This process will never stop. You never get a max, right? So I need that closed interval to give me a place to stop, right? I need to be able to stop on the function and say, hey, what's the height here? So when I'm finding criticals, I don't care about criticals outside of that interval. I don't care about criticals that match the endpoints because I already know the heights of the endpoints, and I only care about criticals that are inside. So inside that open interval. And you'll see if you do enough problems, you'll get some criticals on the endpoints, and then you'll check them again anyway. But you realize, oh, I already know that height, right? Because we haven't done a problem yet, so it's a little confusing what's going to happen. But let's do a problem. So from the textbook, so 45, 47, 49, those are all good. 51. '53, 55, they're all good. Let's do 57. Have I talked to this class about Honor Society? Phi Theta Kappa Honors Society, did I mention that yet? So you want to consider joining. It's the National Honor Society of Community Colleges. I got $5,000 from being a member when I transferred to university. So it's a good thing to do. And if you need a letter for it, let me know. I'd be happy to write you one. So this is number, and there's actually an honors program here. If you take an honors class here and get an A or B, they give you cash money. So look into that too. 4.2, number 57. I think it's like $600 or something. So there's my function, and I'm going to restrict my domain from 1/2 to 4. I think I'll do this one on the calculator. So in my y equal, I'm putting in x raised to the -2 times ln of x. Hopefully you've looked up the process to restrict your domain. I'll cheat a little bit. I'll restrict my domain by changing my window. So I'm gonna take my window and put my x-min at what, 1/2, I said? And my x max at 4. So I'm cheating it a little bit, but so what? And then look at my graph. It's a horrible, horrible window, but I don't know if you can see it in the bigger box on the right. Do you see that little bump for the high part? And the low part is obviously at the left endpoint, right? Do you see that? Yeah. I can zoom a little bit in terms of my Y's to maybe make it look a little bit better. I'll just change my Y. So right now my Y max, I'll change it to Y min -3, Y max 2. I'm randomly picking that based on what I'm seeing here. So now I can see that top of the hill a little bit better, right? And you see it coming back down again, right? So I could really, really emphasize that by, it looks like a Y max of maybe 0.5. And then I'm definitely going to see this thing coming back down a little bit, right? You got to play around with the calculator. You got to, get comfortable with it. It's really kind of a nice little safety net. You can check everything if it's right or not. Nice. So we got to find our endpoints, right? So the question is find the absolute min and max. The function is obviously continuous, right? They gave me the closed interval, and I know my first step is graph it, done, and then find the height at 1/2 at the first endpoint, right? So this is ln of 1/2 over 1/2 squared, right? X to the -2 is 1 over x squared. So I get 4 ln of 1/2. And you can get me a decimal, you can get the decimal for yourself, but I already know that ln of 1/2 is negative, right? So this is some negative number. I want to find f at 4. So I get the ln of 4 over 16. Positive, right? When does ln start being positive? After 1, right? Ln of 1 is 0. Ln of anything bigger than 1 is positive. So this is a possible max for me, right? And this is a possible min, yes? Well, I already know the answer because I can see the graph, but this is my point. I'm telling you, you're going to know the answers before you do the calculus, because calculus is easy. Algebra's not. What's the next thing on my list? Yeah, derivative. Yep. So I could do product rule or quotient rule, doesn't matter. Do what you want. Nice. So dance. Anybody get this? Anybody need another minute for the derivative? One more minute. Yep. A reminder that midterm grades are meaningless other than helping your advisors plan your next semester or lighting a fire so that you get to work. Work, what's up?
So on the first half, you just find it
Yeah, so I'm trying to find where I might have the top of a hill or a bottom of a valley, So I got to find the critical values of the derivative. You with me there? Yeah. Anybody get the derivative? Nice. You're making me worried. Only one of you got the derivative. Kennewauk, you didn't get the derivative? Okay. Okay. Injun, you get the derivative? Okay, thank you.
So when we get there, that is C.
Yeah, I'm about to find a critical value.
So wherever you put that in F,
Yes, then I put that in F. Yes, you're doing 2 steps ahead of me. Right? So I found my derivative, yes? Then I have to find the critical values of the derivative, right? So f prime of x equals 0 implies 1 minus 2 ln of x equals 0. And so we're back in pre-cal again. That means what? Ln of x equals what? 1/2? Which means e to the ln of x equals e to the 1/2. So x is the square root of e. So to subtract the 1, divide by -2. Subtract 1, divide by -2. What is, so subtract 1, this is what we used to do, right?
oh,
Divide by -2.
oh yeah.
Yeah, so positive, right? Is that between 1 and 4? Yeah, square root of 2, 2.7, right? Between 1/2 and 4, yes? Because it's not. Subtract 1, right? So -2 ln of x equals -1. Divide by -2, right? It's okay. Lynn just asked the same. Min just asked the same thing. It's okay. So square root of e does belong to the interval. It belongs to, what was it, 1/2? Yeah, 1/2 to 4, right? Definitely square root of e is square root of 2.7 something.
How do you get the X?
I have to solve for x, right? So I got ln of x is 1/2.
Yeah.
Cancel the ln by raising base e. So e to the ln of x equals e to the 1/2.
Yeah.
E and ln are inverse functions, so they cancel each other. So I get x equals e to the 1/2, or square root of e. I have to get my criticals from downstairs as well. F prime of x does not exist implies x cubed equals 0, right? Remember, numerator equals 0, denominator equals 0. So when is that? That means x is 0, right? But 0 does not belong to 1/2 to 4. So it's no good. I don't need that critical. I don't need that critical at all. Nope. Nope. Because my ultimate goal and my conclusion is, hey, this is the highest point on the curve. This is the lowest point on the curve, right? So going through the process of finding criticals that turn out to not help you at all, who cares about them? So now I found the only critical that is in my open interval. I need to find the value of the function there, right? So f of the square root of e is the ln of square root of e over square root of e squared, right? ln of x over x squared. What do I get for the numerator? What happened to ln and e? What do they do to each other? So yeah, so I get 1/2, right? The power is a 1/2 power, and square root. What? What? Yeah, e to the 1/2 power is the same thing as square root of e. E to the 1/2 power is the same thing as square root of e. Yes. Yes. So I get 1/2 over e, right? Which is 1 over 2e. Let me put numbers. Mint. 1, 2, 3, 4, 5. Which line are you looking at?
3.
Yeah, so 3, it says e to the ln of x equals e to the 1/2.
The ln is like above the e. Right?
Yeah, it's a power.
It is, yeah. So for that one, like ln is times to e.
No. E raised to the ln of x. They're inverse operations. You just get x. E to the ln of x is just x.
Yes.
Yes, done.
Yeah, but I mean that's why. How do you get 1/2 from there?
We did the 1/2 already. Subtract 1, divide by -2.
For the below,
So line 2 we agree with. ln of x equals 1/2. Raise both sides to base e. Left side, e to the ln of x. Right side, e to the 1/2. What happens on the left side? E and ln cancel. They're inverse operations. So I get x equals e to the 1/2. Or square root of e. Why do I like square root of e better? Square root of e. How many strokes? 2. E to the 1/2. How many strokes? 4. I'm a coder. I want to tell you as much as I can with the least amount of memory. Well, let's take a look. We already see our curve. Our curve's doing something like this. And so here we got what? 1/2 comma, I forget already. 1/2 comma 4 ln of a half. That's our min value. And here we got square root of e, 1 over 2 square roots of e for our max value. The book will sometimes give you a point and sometimes just the y value, but be sophisticated enough to give them both. I know that the highest point on this curve is 1 over 2e. I know the lowest point on this curve is 4 ln of 1/2. So x to the minus 2 times the ln of x. And I'm restricting on 1/2 to 4. I don't want to be in the trig world. At 1/2, I got the height of 4 ln of 1/2. Kind of nice to write that differently as what? -4 times ln of 2. You see that? Right, reciprocal is a negative exponent, right? So that negative exponent moves out front. And then the other point I had was square root of e, comma 1 over 2e. And there's my max. Pretty sweet. And of course, the other point I got was useless, right? What was it? 4 comma ln of 4 over 16. Done. Easy. These are very easy to do. So do a bunch of them. Go to all of my chapter 4 tests, do every one that I have on there, go to my final exams, go do every one I have on there, right? Ask for help. Yes? You got to start asking for help. You're not making me work very hard. I'm cruising right now. I'm not working very hard. I should have 11 of you at my office every day. In my other class, I should have 14 in my office. At least once a week, you gotta get your questions answered. Maybe somebody in the class is helping you, great. Maybe you're going to Dr. Early, great. Maybe you're going to the Math Learning Center, great. If you're not doing one of those, you're not doing what you need if you're failing, right? You have to get serious. You can't lie about it. You can't pretend it isn't there. It's a cavity. It's going to keep rotting until you're in pain. Nice. Let me stop this recording, start a new one for the project, okay? Just because it's so long.